Let's be honest, if you've ever had to deal with data migrations, pipeline upgrades, or just trying to prove that two massive datasets actually match, you know the absolute headache it involves. It's rough. But today, we're diving into this explainer to unpack the Recon framework. It's this awesome new open source project that's finally bringing some much-needed, strict software engineering rigor to the messy, chaotic world of data comparison.
Just think about the stark contrast between our incredibly streamlined code repositories and our sprawling, totally unorganized data lakehouses. With software, right, we have version control, pull requests, automated testing, the works. But with data, man, we're often just living out of shared folders, running some random SQL script called prod v1 final v2, and just crossing our fingers that someone didn't accidentally overwrite a crucial table. It's a fundamental disconnect, isn't it?
So we desperately need a paradigm shift here. We have to move away from these frantic manual spot checks and toward a really structured version-controlled methodology. The old way totally relies on humans just remembering to run the right script or staring cross-eyed at massive CSV files. But the Recon way introduces these things called versioned equivalence contracts and generated evidence artifacts. It's really about finally bringing true reproducibility to data validation.
Basically, Recon replaces those isolated, one-off tests with a durable, rock-solid standard called reconciliation as code. And what does that actually mean for you? Well, it means your reconciliation logic lives right there in Git, right alongside your pipeline code. It's entirely human-readable, it uses these reusable check packs so you aren't constantly reinventing the wheel, and most importantly, it strictly produces evidence. You get an auditable trail of exactly what was checked and what failed.
Now, at the heart of this entire framework is the equivalence contract. You can think of it almost exactly like a strict versioned legal agreement, but for your data. Instead of just a single isolated test, this contract defines the entire relationship. Like, what are we actually comparing? At what grain? Which columns actually matter to us? Are there sampling rules because the dataset is, petabytes large? All of that is declared right here in one single source of truth.
And within that contract, we establish super clear roles. See, we are comparing canonical business outputs here, not just blindly matching database primary keys. Your source is your baseline. Maybe that's an old pipeline output. And your target is what you're validating, like a newly replicated warehouse model. Recon actually allows you to compare the real business logic across these layers without forcing generated surrogate keys to match perfectly if they literally don't matter to the business.
This brings us to an absolutely foundational rule of Recon's architecture. And it's this. You author the configuration, but you never commit the generated artifacts. Your authored YAML files define your intent, right? Everything else, the compiled plans, the SQL queries, the failure reports, those are all generated artifacts that just live in get-ignored folders. Because honestly, a change in your data shouldn't force you to commit new messy complexity to your clean repository.
Okay, so to keep everything highly predictable, Recon strictly separates its CLI lifecycle into three distinct phases. First up, we parse, reading the files and building a machine-readable manifest. Next, we compile, which expands those readable files into explicit, typed check plans. And finally, we run, that actually executes those plans against the database and collects the evidence. It creates a really clean, solid boundary between what the user intends and what the database actually executes. And by compiling first, the framework acts as a massive safety net. It explicitly shows you exactly what will run, and it automatically injects vital safety checks, like null key and duplicate key checks, before it even attempts any row-level comparisons. Because if you try to compare rows without unique keys, a standard script might quietly give you a totally misleading result. Recon's compiler intercepts that ambiguity right out of the gate, so your comparison doesn't give you a catastrophic false positive. This boundary we just talked about, it's the absolute secret to Recon's portability. The core is the brain of the operation. It defines what reconciliation actually needs to happen. It understands complex semantics like missing keys or aggregate differences. But get this, it doesn't need to know the exact dialect of SQL your specific data warehouse uses. That is the adapter's job. Adapters are essentially the plugs that render those plans into execution requests tailored perfectly to your specific system.
So while the current codebase leverages DuckDB as this awesome in-core local development adapter, this whole architecture paves the way for a massive ecosystem of production connectors down the line. We're talking Postgres, Snowflake, BigQuery, and even semi-structured systems like MongoDB. The adapter interface keeps the core super lightweight, which empowers the community to build out support for virtually any data platform on the planet.
Now here's what's incredibly exciting, especially for open source developers.
Recon Core is currently sitting at pre-alpha version 0.0.0. Yes, literally 0.0.0. This isn't some lockdown decade-old tool where the foundation is completely set in stone. Not at all. It is a highly active, rapidly evolving framework that's being built in the open right now, aiming to solve one of the most frustrating, hair-pulling problems in data engineering.
If we take a look at the active changelog, the momentum is just amazing. Recon can already parse your contracts, it generates typed check plans, and handles DuckDB SQL rendering. But the next major frontier, and this is where community help is so incredibly welcome, is building out the actual execution engine, formatting those run results, and splitting out those external production adapters. It is very much an in-progress labor of love.
Major foundational pieces are shipping as we speak. Just recently, they added built-in helpers for row counts and key coverage, along with explicitly compiled metric checks for aggregate comparisons, plus that awesome DuckDB SQL rendering we mentioned. The project is moving incredibly fast to establish a really robust foundation, one that treats your comparison logic with absolute respect.
And here is a crucial takeaway for you: absolute strictness. Recon flat out refuses to silently guess. If your database adapter doesn't support a specific check or a capability, Recon won't silently pull gigabytes of data into Python to try and resolve it locally behind your back. No way. It gives you a crystal clear diagnostic and fails early. Because when we're talking about data validation, trust and safety aren't just nice-to-haves. They are literally everything.
Because this is an active, community-driven project, consider this your ground floor invitation. Seriously, go star the Recon repository, fork the code, and help write the adapters that are going to solve data migration nightmares for everyone. Being at version 0.0.0 means your input literally shapes the framework. Whether you want to contribute new check packs or just test out the DuckDB renderer locally on your machine, there is a place for you here.
So, let's wrap this up. Data reconciliation has been a chaotic, unengineered mess for far too long. But with Recon, we finally have the blueprint to bring the order of software engineering to our data lakes. I'll leave you with this. Are you going to keep relying on chaotic, ad hoc scripts and just crossing your fingers during your next big migration? Or will you join the community and help engineer the cure? Grab the pre-alpha, star the repo, and let's start building the future of data validation together.